Hello, I'm Jason, and welcome to this section of the Calculus 1 Extra Practice with Integration DVD. In this section, we're going to cover what we call the fundamental theorem of calculus. And as you can guess, with a title like that, it's pretty darn important. Basically, what we've done in the last section is we presented motivation for what an integral is, to give you that warm, fuzzy feeling of what it represents more than anything else. Here we're going to start to learn about how you actually calculate integrals and sort of what the big picture is there. The fundamental theorem of calculus really is geared around telling you how to basically calculate integrals. So we're going to learn a little bit more about here, and then we're going to do a lot of problems in subsequent sections to give you that practice. So the fundamental theorem of calculus, there's a couple of things I need to write down because they're in all the textbooks, and you need to make sure that this is true anytime you're doing an integration. So you're going to let some function f of x be continuous. Continuous on some interval a, b. So what this means is that your function is smooth. There's no jumps, right? So, because you can't have crazy functions where it goes up and then it just discontinuous jump down to some other value, right? Like some piecewise defined function or something. So basically what you mean here, when you look at this in a book, is it means smooth functions. That's what a continuous function is. Nice, smooth changes. I mean, they can be steep and all. You just can't jump discontinuously from one point to the other. So it has to be continuous on the entire interval that you're integrating over in order for integration to work. The second little thing is we're going to let something called the antiderivative, and I'll explain what that is, derivative of f of x be denoted as capital F of x. Notice the function we're integrating is f of x, little f. The antiderivative, which I need to explain in a minute, is denoted by a capital F. All right? Once you let those two things be true, then the following can be defined. Because if you don't have a continuous function, then you can't do any of this stuff. Then the integral from a up to b of f of x dx, which we talked about what all this part means, is equal to the antiderivative of f evaluated at the top limit of integration minus the antiderivative evaluated at the bottom limit of integration. This, believe it or not, is actually the fundamental theorem of calculus. And there is a picture that goes along with it, so let me make sure I can draw the picture for you real quick. So if we're looking at x, and this is f of x, our function can be anything we want as long as it's continuous. It can go, let me change colors. Our function can do something like this. Whoa, up high and then down low like this. All right? And what it's basically saying is, if I pick a point A, and I pick a point B, then to find the area underneath this curve, all the way from A to B, like this, you're going to take the integral of the function over dx from A, the lower limit of integration, up to B, the upper limit of integration, and in order to get the answer, you're going to find something called an antiderivative, which I need to explain what it actually is, but it's another function, basically, that's denoted by capital F, and then once you do that, you evaluate the antiderivative at the top limit of integration, and you subtract the antiderivative evaluated at the bottom limit of integration. So what you're doing is you're getting a number, because when you do this integration, you're going to get